Welcome back, students, to one more session of your unit 1, that is chemical reactions and equations. Right, till now we have done the balancing of reaction. We have studied the characteristics of the reaction. You have already seen the animated video for all these. Let us today start with the different types of chemical reactions. I think in the previous video I have given an introduction of the different types of chemical reactions. What are there? Combination reactions, decomposition reaction, displacement reaction, double displacement reaction, redox reaction, as well as disproportionation reaction. Right, today our topic of discussion is combination reaction. Simple. Before going into the topic, let's see what actually is the general statement or the general discussion about combination. If I say combination, what are the names suggest? Combination, something is combining. Simple. Suppose there is an element A, it's combining with element B, it's going to form a compound AB. That is nothing but combination, right? It can be A, B, C also, right? So let us write the definition now. So if I have to write the definition of combination, now see here, just in simple words only we will write, but perfectly we will write. What does it mean? Combination reactions are those reactions in which two or more elements combine together to form a simple compound or a single compound, right? Simple, that is right. Combination reactions are the reactions that all you write, the reactions in which I'm writing from in which two or more elements combine together to form a single compound. Two or more elements combine together to form a single compound. Understood, isn't it? So here, simple. Suppose this is a marker. The top part and the bottom part together we're fixing and forming a pen, isn't it? Right. Simple example I have given. Right. So here, in the different way, if I have to write the reactions in which one compound is formed from two or more reactants. Simple, right? That also you can write. Let us write a reaction. Combination reactions are those reactions in which one compound or one product is formed. So we know these are the products, we know these are the reactants, is formed from how many? Two or more reactants. So if you write products, you will be writing reactants. Simple. If you write compound here, you will be writing elements there, right? Right. Or if you write compound, you can write atoms also, no problem. So this is the definition. Now I know. Now I'll take out the definition and what actually should I learn in combination reaction. Little bit lengthy, let us understand. So basically combination reactions, when I speak, there are two varieties of headings which we are going to study, right? We'll be studying the reactions in under which heading? One is exothermic reactions, and let us underline this. Then I'll be studying under one more heading, that is endothermic reactions. Right? So exothermic reactions and endothermic reactions means what? Right, let's see. So exo means what? Exo means giving out. Endo means what? Endo is nothing but taking in, correct? Thermic means what? Therm means heat. Thermos flask we say, na, where you pour the tea and keep so that it's hot. Thermic means heat. So the reactions in which, the reactions in which heat is released out is called exothermic reaction. Let us come here, same. Thermic means heat. Let us see. The reactions in which heat is absorbed is called endothermic reaction. So here for your grade 10, you have different examples you need to study. So I'll be teaching the example of exothermic under or taking the example of respiration. So remember, respiration comes under the heading exothermic reaction. When it comes to endothermic remember, photosynthesis comes under endothermic reaction. Photosynthesis of plants, where they absorb heat or energy from the sunlight, right? The next thing in exothermic, I'll be giving you an example of the whitewash reaction. Whitewash reaction, very famous, important also, whitewash reaction. So under respiration, important, nothing, we'll be studying about the cellular respiration, where we'll be talking about digestion of food, right? So next one, okay, I think this is not, the marker is not clear, I'll change it, students. Right, after the whitewash reaction, where we'll be using quicklime, next comes, we'll be learning a reaction that is nothing but burning of natural gas. So burning of natural gas comes under exothermic reaction. Next, burning of coal also comes under exothermic reaction. Next, if you have to speak about burning of magnesium ribbon, also comes under exothermic reaction. Next important thing, decomposition of natural or the decay, the whatever vegetable matter you have, the converting into compost by microorganisms, that also. So the decomposition or conversion of vegetable matter into what? Compost. We will be seeing everything, don't worry. Reactions also I'll give you into compost. These all come under exothermic reactions. Now when we speak about the endothermic reactions, photosynthesis is the first most important endothermic reaction. After this, we'll be studying about the conversion or the formation or converting of ammonium chloride solid, that is ammonium chloride solid. It will get it will dissociate, and while forming compound, it will form it requires energy to convert into, okay, let me put like this, it requires energy to convert from solid to ammonium chloride ammonium chloride vapors. This one, gaseous state of that, means the vapor forms of that also I'll explain. Next, after this, I'll be, or endothermic example if I have to take, baking of bread. Baking of bread is an endothermic. You would have seen, isn't it, in your oven, when your mom she sets a preset temperature, she will set 360 degrees for baking the bread, she will on it, so it will get preheated, means it will first absorb the heat, store it, and then use it for baking the bread. So baking of bread comes under endothermic reaction. Then melting of ice, means the conversion of liquid water to ice. It is going to absorb heat, or it's going to absorb energy, and then only form ice. Next, so I think I have covered almost all the examples. And next, conversion, that is conversion of solid, or let us say sublimation of carbon dioxide. So carbon dioxide sublimation, we very well know what is sublimation, nothing but conversion of solid directly to the gaseous state. So these are the examples which I'll be dealing one after the other. Combination reactions, a little bit lengthy video, but you will enjoy it, so please note it. So combination definition I know, examples of exothermic, endothermic I know, definition of exothermic, the reactions also I've already told. Let us see the reactions in which heat is absorbed are called exothermic reactions, or the reactions which require heat for converting reactants into products. Endothermic reaction exothermic are the reactions in which heat is released or evolved during the reaction. Endothermic reactions where heat is absorbed during the reactions. Let us come and do one reaction, keep noting it. Right, students, we have seen the definition of the combination reaction. Now let us go and see the examples of the exothermic reaction. That's the first example. What is the first example? We said important. Respiration comes under exothermic reaction. So respiration is a process. Now cellular respiration rather. Here what is happening during digestion of food? Important. So I am going to take the example of during digestion of food. What happens? Basically we have carbohydrates. Our staple food is rice, isn't it? So whatever carbohydrates are the carbs which we say. So the carbohydrates, what are carbohydrates? For example, rice, potatoes, which has starch in that. So all these carbohydrates, different carbohydrates are there, right? So when these carbohydrates are consumed, you are having that carbohydrates, what happens? This carbohydrate breaks down or breaks up into what? Into glucose. So first thing is glucose. It will break up into glucose. So what happens to this glucose? This glucose is going to combine with the oxygen which is there in the cells, right? And it's going to form three different compounds, that is your carbon dioxide, it's going to form water, and it is going to release large amount of energy in the form of ATP. We call it as ATP, adenosine triphosphate. So if I have to write the reaction about this, so first important thing, here I have written exothermic reaction and I said energy is released. See here, energy is released. So this is out on the product side. So remember, if you write exothermic, energy or the energy should be mentioned on that side, right? You can also write in the form of delta, that's heat, but here in this case energy is released in the body, so that energy when we have food, and finally the outcome is that. Now let us write the reaction. So glucose formula, here I am writing C6H12O6. Okay, then it's going to combine oxygen from where? Cellular, which is there in the cells, and as I said, it's going to get converted. I'll take out this ATP from here. I don't have place, I'll write here. Okay, it's going to form carbon dioxide, it's going to form water, and it's going to form energy. Now here carbon is 6, so I'm putting 6. Here hydrogen is 12, already 2 is there, so I'm putting 6. 6 2s are 12. Now oxygen is 6 plus 2, 8. Oxygen here is 6 2s are 12 plus 6, 18. So what should I put? Just say some students. So here if I put 6, let's see. 6 2s are 12, 12 plus 6, 18. Over, isn't it? So okay, so here also oxygen, so the reaction is glucose formula C6H12O6 combining with 6 oxygens to give me 6 carbon dioxides, 6 water, and energy. Simple. So this is your respiration reaction, that is during digestion of food. This is what is going to happen inside the body, right? Now this is one example I understood. Now next I need to take the reaction that is nothing but whitewash reaction. Let us write that the next type of respiration reaction, the next type of exothermic reaction is nothing but whitewash reaction. So here whitewash reaction. So here whitewash reaction, that's fine, but what actually should you remember? Let's see. So again, this is also an example of exothermic, energy is released. What you are going to do, you are going to take solid calcium oxide. So solid calcium oxide, what is the name of this? It is white in color, name is quicklime. Okay, this is quicklime. Let me underline this with the marker quicklime. I'll tell you why I have underlined. Right. After that, what happens? You're going to mix water to this. Water, I think H2O is the formula. Can I write water like this? HOH? Simple. Now these together, when you add calcium oxide in a beaker, add some water and stir it. You just with a spatula, immediately what happens? It mixes up together and it forms calcium is 1 OH, 2 OH. So together it forms OH2, calcium hydroxide. What is the name of this? This calcium hydroxide is also called slaked lime. Slaked lime. What is the other name of this? Lime water. This is also okay. Done. So over. Now further what I am going to do, this calcium oxide mixed with water, calcium hydroxide is there. This calcium hydroxide, it combines with the atmospheric carbon dioxide. So in the atmosphere carbon dioxide is there, isn't it? Right? So this, from where we got? From the atmosphere. So from the atmosphere it combines with carbon dioxide. Further these together combine and it forms a compound that is nothing but calcium carbonate. Calcium CO3, calcium carbonate. Right. So this calcium carbonate and the leftover water, that's different. Now this calcium carbonate is what is called the whitewash. So what happens is, once we form this, once the calcium hydroxide is formed, so it combines with slowly after, it combines with the carbon dioxide, and after 2 or 3 days, it will form a white coating on the walls. That is what you see, no? When they apply chuna, we say, when they apply it on the walls, after 2 or 3 days, it becomes full white, because what happens? The conversion of the slaked lime using atmospheric carbon dioxide, finally it forms a compound calcium carbonate. So the other name for marble also is calcium carbonate only. Okay, limestone. Right. Now here, what is important? Here we are going to take a combination of the ratio 1:13 combination we take. Now important thing is, this calcium carbonate, whatever is there, it gives a shiny white surface, shiny white coating. It gives a shiny white coating on the surface of the walls. It becomes, when you whitewash your walls, it looks white, not immediately, but after 1 or 2 days maximum. Right. So that gives a shiny white coating to the walls. And important thing here is, in the whitewash reaction, when they say three things, or rather 2 things you need to say. That is, first thing, whitewash reaction starts from here. That is reaction of, how do you say? Whitewash reaction is reaction of calcium hydroxide with atmospheric carbon dioxide to form calcium carbonate after 3 to 4 days, and which gives shiny white coating, is called whitewash reaction. But from where is this calcium hydroxide formed? It is formed from the basic calcium oxide, that's nothing but quicklime. So this whole example is called whitewash reaction, but specifically from here till here. What is the ratio? 1:13, right? Now, important in the exam, why did I underline? Quicklime is one. This one formula, students, you need to study. Slaked lime is one formula, or lime water, then marble. So these are the formulas which you should need to compulsory study. Most of the students say, ma'am, I'm not remembering what is quicklime, what is slaked lime, nothing. Write this, note it, and then memorize it. More number of times you practice, you will get it. Now let's come back and see third type of exothermic reaction. What is that, students? Burning of coke, burning of magnesium ribbon, and burning of natural gas. Right. Now let's come and see the next example of the exothermic reaction. That's nothing but burning of natural gas. Okay, so here first important thing, when I write natural gas, I should know what is natural gas, isn't it? So natural gas is nothing but methane gas. If they ask you what is LPG gas, it is nothing but N-butane. N-butane is what is there in your LPG gas, right? So natural gas I'm going to take, that is methane gas. But remember, in the natural gas, along with this methane, basically methane is called alkane. Ma'am, what is alkane now? New thing. Okay, so in chemistry, the organic chemistry, we have different classes of functional groups, or different class of compounds, alkanes, alkenes, aldehydes. Means there is certain amount of functional group which will give the property or give the compound an identity. Suppose if I say, what is your name? You tell your name. If I say, tell me your characteristics. I'm 5'5" or 5'5" or 6 feet tall, or 5 feet tall. I'm fair in complexion or wheatish. So those are the characteristic of you, or it will explain about you. In the same way, for a chemical compound, there is certain thing called functional group which will explain the characteristic of that particular compound. In the same, like that, we have a compound called alkane, single bonded compounds, alkenes, double bonded, alkynes, triple bonded. Don't worry, I'll be teaching about this in your fourth chapter, carbon and its compounds. Now, as of now, remember, natural gas is nothing but it is made up of methane and alkane. Along with this alkane, it will also have in this different types of alkanes, different other combination, different types of alkanes, different types of alkanes. Along with this, it will also have nitrogen, it will also have hydrogen sulfide, it will also have a part, means little combination of the hydrogen sulfide and little combination of sulfur also. Like trace means little quantity. So all these together forms a natural gas. But now what is important, in this natural gas I am going to burn it. So when I combust it or burn it, I require oxygen. Always remember, this is called hydrocarbon because it has hydrogen and carbon. So when hydrocarbons are burnt, I am writing one more sentence. When hydrocarbons are burnt means they are heated in the presence of oxygen. So if they are heated in the presence of oxygen, always the products formed are only two, that is carbon dioxide and water. So when hydrocarbons are burnt or combusted, I'll be getting two compounds, that is carbon dioxide and water. Here let it be, this is called methane. Methane is a natural gas. Even if I take ethane, if I take propane, butane, we'll be getting carbon dioxide and water. Right, so the natural gas burning, but what is important here, I said during this process, this is an exothermic reaction. There is amount of energy which is released. Now I wrote energy outside means what is the type of reaction? Exothermic. Now where will I use that energy? I said these energies or whatever is released, that is during the combustion of natural gas, we use it in the form of for cooking. In villages you see, right, they put the methane, they burn it, they generate energy from that and use it for cooking. So the energy which is released as a part of exothermic, I use it for heating, I use it for cooking, I use it for generating electricity also, and few cases we use it for manufacture of plastics also. Manufacture of plastics is also one of the use. So what is important here, using natural gas, and that too the concept of combination reaction, two combining, and that too by releasing energy, and that energy we are using it. There are a lot of uses. I just gave you the main thing. So this is the information about burning of natural gas. Now if I have to speak about burning of coal or burning of magnesium ribbon, let us take that, let us erase this. Okay, right, here the same thing, instead of natural gas and coal, so let us write that also, whether it is exothermic or not. So here we are going to write burning of coal. Okay, here burning of magnesium ribbon, So here burning of magnesium ribbon, let us see the example also, ribbon, yes, that which you use during your Diwali crackers also, right. Coal, what is the formula? It is nothing but carbon compounds. So when you are burning coal or combusting it, it's going to form carbon dioxide. Yes, so along with this, when you're burning, there is a lot amount of energy which is released. That energy also has lot of uses which we'll be seeing now. Here when we speak about magnesium ribbon, magnesium I am taking ribbon. First, whenever you're using magnesium ribbon, you need to rub it with a sandpaper so that you will take out the oxide, and take that magnesium ribbon and you heat it in oxygen. Immediately it will start, just like your Diwali crackers, how it will start giving dazzling light. It burns and it forms a compound called magnesium oxide. So nothing but ash. Now here two compounds are combining together to form a single compound. Is it not combination? Here also two compounds are combining together, or sorry, two elements are combined together to form one compound. Is it not combination? Along with that, lot amount of light is released. So energy is released, light is released. So all are combination reactions only, all are exothermic reactions only. Right. Here further, if I have to see burning I have seen respiration, I have seen whitewash reaction. I should see one more reaction, that is nothing but decomposition of vegetable matter. So decomposition of vegetable matter is what is important. Now here in vegetable matter, we very well know, remember, see, vegetable wastes will be there, right? In that also bonds are there. Yes or no? Without bond, there is no compound, isn't it? So in this vegetable matter, it will store the energy in the form of potential energy. So vegetable matter has lot of potential energy in it. So what happens here, whatever vegetable matter is there, so the potential energy is nothing but the inbuilt energy which is there. What happens when you discard the vegetable matter, all the microbes what are there, just like your bacteria, some insects are there. So bacteria is one, some insects are there. So what happens, what they do, these bacteria or insects, they go into the vegetable matter and they break the bonds. When they break the bond, it turns or converts into compost, and which contains, compost has carbon dioxide in that. So that bonds are broken down, and during that process lot amount of energy is released. So this lot amount of energy is nothing but exothermic reaction. So here during this process, as I said, carbon dioxide, you can see that smell also, yeah, and we use that compost as a good fertilizer for growing your plants, correct? Right. So here everywhere chemistry is involved. Here basically exothermic reaction, we have listed out what we spoke about. Combination definition, we spoke about types of exothermic. In that respiration we spoke about whitewash reaction. We have seen burning of all the three, which natural gas, methane, that is coal, vegetable matter, as well as magnesium ribbon and methane also. So let us come back and meet or learn the endothermic reactions. Right. Now let us come back and see the endothermic reaction. So what is endothermic? That means, let us define this. So reactions, as I said, endo means absorbing in, thermic means heat. Okay. Reactions in which heat is absorbed, it's called endothermic reaction. So the best classic example for this is nothing but your photosynthesis reactions. So photosynthesis we very well know, because of the presence of chlorophyll present in the leaves of the plant, they absorb the sunlight. So what is happening during this photosynthesis, we very well know carbon dioxide, whatever is there, right? It's going to combine with water, which is there. We drop water to the plants, right? So the carbon dioxide is whatever is released, that combines with water, right? During this process, it requires sunlight. Compulsory, the leaf requires sunlight to complete the photosynthesis. So carbon dioxide with water together combine and form nothing but glucose in that. Okay, let me write this glucose little bit down so that you know the formula. So what are you observing here? C6H12O6. So these two together form this compound. Along with this, the energy, okay, I should not write here already energy is taken in, correct? Now here carbon is 6, here carbon is 6, here hydrogen is 12, here hydrogen is 6. So oxygen is now 6, but here oxygen is 6, 2s are 12 plus 6, here 18. So what should we do? Shall we write this in the form of 6? Let's see now. Okay. Let us see the reaction. I think little bit balancing. Let's come and see whether anything is left out also in the reaction. Okay, so as we know in the photosynthesis reaction, what is important? Carbon dioxide absorbed, and then the oxygen is evolved in this. This is what we forgot to write. Now let's balance. Now 6 carbons are here, 6 carbons are here, balanced. Oxygens are 12 plus 6, 18. So here already 6 is there. I'll write 6 here over. Now here hydrogens are 6 2s are 12. Here also hydrogens are 12. So this is what is your photosynthesis reaction. Now what are you observing? Observe carefully. If I write in this reverse order, now if I write in this order, it is photosynthesis. When I do this order, it is nothing but respiration reaction, isn't it? So what am I trying to say? Photosynthesis is an endothermic reaction. Respiration is an exothermic reaction. Both the reactant forward photosynthesis I get, backward respiration I get. So this is your photosynthesis reaction, right? Now next thing in endothermic, but what is important here, if you see, the sunlight is what is absorbed in by the leaf. The sunlight, in the presence of sunlight only, it's going to form glucose, which is used as a food. But what is released out? Oxygen. So plants release that, isn't it? Right. So here this is over. In the next endothermic example, when I take, I am going to take the ammonium chloride. So what happens? Ammonium chloride, here I am going to take solid. Right. Here what it does, it's going to absorb heat, or it's going to absorb energy or heat, let us write. So when it absorbs, the bonds are broken together, and the ammonium chloride, it gets converted into aqueous, means aqueous form, the liquid form of that, aqueous form of that. And this is this process, and as I said, I am supplying energy to break the bonds of solid, and I finally forming the aqueous form of it, means the ions are released, ammonium ion and chloride ion. So isn't it an endothermic reaction? It's not taking, it is absorbing heat. Now as I said, other than this, what are the different examples of endothermic? I also said burning of sublimation of carbon dioxide, and I also said baking of bread. I also said melting of ice. So endothermic, I should have clarity. Exothermic, I should have clarity with all the examples. So end of the video, you will be also watching a combination reaction activity in the form of an animated video. So thank you for watching, students. I'll meet you again with the next type of reaction, that is displacement reaction.